I'm really excited about this opportunity to talk about my research and maybe get more people excited about machine learning and computational methods in applied linguistics. I would also like to thank everyone who's here attending. That's an impressive list of different countries. This is really exciting. So I'm just going to start by talking about my motivation for this talk. If you were here for Mike Scott's webinar last week, you might remember he mentioned a climate change corpus he was working with some colleagues that originally had like 30 million tokens or words, and that they made it more manageable by sampling it, like 10% of it, to a smaller corpus of 3 million tokens, which is still a big corpus. So we can see that we are getting bigger and bigger corpora, and that can be really overwhelming. If you just look at the English corpora from BYU, and I understand Mark Davis is speaking also next week, you see that just the English corpora, right? Not looking at the Spanish corpora and the Portuguese corpora, you can see that these are like 14 billion words, you know, like 400 million words. These are huge corpora, which is great. It's a great resource, but it can feel overwhelming, right? So we have this mantra or this saying in data science that 80% of your data science is data wrangling. So you have like to fight your data and try to like control it, right, and make sense of it. And 20% is data analysis. This is in corpus linguistics. If you have a corpus that is already ready to use, let's say like the ones provided by Mark Davis, if you're building your own corpus, that's like, I would say like 99% struggling with your data and 1% data analysis. We're lucky that there is a lot of tools out there and technologies that can help us with that. Some of these are machine learning related. So I'm going to be talking a little more about that today. And at the end of the talk, I'll give you some resources on where to start. And I hope to get you excited about this so you can think like, yes, I can do this. I'm going to start like working with data, science, and machine learning. Okay, so what is machine learning? So the standard answer for this question is it's learning from data. So you have some data. In our case, we have a corpus. And you want to learn something about that data. And usually, traditionally, for machine learning, so you have a corpus of a lot of email messages, and each message is labeled with email, with spam, not spam, so that in the future, when you get new incoming messages, then each new message, the system will label that as a spam and not spam. I'm also very much interested in the explanation power of these machine learning models. So to actually look inside the model and see what features, or in my case, like what words or what bigrams have more weight in these predictions or these decisions to try to understand some feature of language use. So if you look at machine learning applied linguistics, there are a lot of things that we already engage with in corpus linguistics that are considered machine learning. So there are two basically like main types of machine learning. There's supervised machine learning and unsupervised machine learning. So for supervised, we have like these problems that we called classification. Like I mentioned, the email example, the spam versus not a spam classification. But we can look also at language choice. So for my dissertation, I looked at copula choice, so ser versus the estar, of L3 Portuguese learners. So So production in Portuguese by Spanish-English bilinguals. And I compared the language choice with the language choice of studying Spanish so that I could look at the developmental paths of L3 Portuguese. So that's an example of a language choice, ser versus estar. You can also have a classification problem where you're looking at group. You have a bunch of essays, right? You have a corpus of essays, and you want to model what features are relevant for high and low scoring essays. So that's like kind of a group classification. There's also a whole set of problems in classification called authorship profiling. So that's like being used for forensic linguistics, but also to attribute texts to whether it was written by a person or not. I'll be talking more today about a native language identification. It's identifying an L2, a second language text, if it was written by a certain L1 or another. I'll also be talking about a citation classification project that I'm involved with. And in this case, instead of the whole text being the unit of analysis or modeling, these are individual sentences that are classified by form of citation and function. Some unsupervised machine learning methods are clustering. And we know clustering analysis from corpus linguistics. So basically, you cluster texts, for example, into groups, right? And then for machine learning, the purpose usually is to predict a new text and what group that text belongs in. I also used word embeddings in my dissertation, which is another unsupervised machine learning method. I'm not going to be talking much today about word embeddings or clustering, but if you have any questions about it, I'm more than happy to expand on this. So I'll be focusing today on native language identification and the citation classification projects. Okay, so this project I started, I was back in 2016. And I had Portuguese texts, so L2 Portuguese, produced by English and Spanish bilinguals. Sorry, not bilinguals, speakers. And the unit of modeling for this project, it was the entire text. It was a journal entry, actually. And this classification problem, in my case, it was a binary classification problem because I had two labels, right? I had a Portuguese text written by L1's English speaker, and a Portuguese text written by L1's Spanish speaker, for example. For this project, I created my own corpus. So I don't know if anyone out there is familiar with Lang8, which is this like social network website where the purpose is to learn additional languages. So if I want to learn French, for example, I go in and I say that I speak English and Portuguese, and then I'll be writing in French, and then I'll be getting feedback from French speakers. So this is a multilingual language learning and language exchange website. Like I mentioned, my target language was Portuguese. So what I did was to go in the website, and all the public entries that were indicated to be written in Portuguese, Brazil, because they had like European Portuguese and Brazilian Portuguese. I was interested in the Brazil Portuguese entries. So this is just an example of journal entry. So this will be one of my texts. And the target L1 background, like I mentioned, there were two types, right? English and Spanish speakers. So I looked at, this is an example of a user. This specific one, Pancake Mix, is a Spanish speaker, so they indicate here in their profile. And they are writing journal entries in Japanese and Portuguese. So in this case, this was added in my corpus as a Spanish L1 label. You also notice that they had the option to add a reference entry, like in this case, this person is translating or doing a version of a text that was originally in English. And you notice that this user doesn't say that they speak English at all, right? So this is, I'll be talking more about this issue, but I just wanted to make clear that this was automatic, right? So I just went by whatever they had in their profile. Okay, so this is the project workflow from beginning to start. So I started with journal entries being scraped in HTML. And then these were converted to plain text. So I had a total which it's common for a lot of methods in corpus linguistics, like multidimensional analysis, for example, right? You have some count for certain features in each text. In my case, I used something that is typical for machine learning to use one-hot encoding. So basically, for each text, I had a vector of numbers. In my case, they were 0 and 1s. And then for each word in my vocabulary, I would have whether that word was present or not in that text. So instead of using a normalized frequency, for example, for each word or each token or feature, I used a 0, 1. So 1 is present, 0 is not present. So after I had that, I had each text converted into a vector of numbers, a list of numbers. Then I divided my data into 3 parts. And that's, again, it's pretty standard for computational linguistics or machine learning, that you have your training data set, which is the data that the model, your algorithm actually sees and learns from. And then you have your test data sets. I had 2 test data sets. I had a development data set because I ran that many times, changing some hyperparameters for the model until I was happy with the results. And then the test data set is the prediction. So this is the very last step. You run the model on the test data set just once. You look at your predictions and how accurate they were. So I'm reporting here just the numbers for the test data, which are going to be always a little lower than the performance of your model in your actually training and development data sets. Okay, so the purpose of this paper was to see what combination of language features resulted in a more accurate model. And I'm going to show you the results. I'm going to give you some time to look at them while I drink some water, because I'm in the desert and talking, it's like in dry weather, is very hard. So I first implemented a support vector machine algorithm in Python with this package, which is very widely used, scikit-learn. Support vector machines is an algorithm that it's very basic. People try it first. And you see that for feature set, I tried a bunch of things. I tried just tokens, so words, individual words, and then bigrams, so sequences of 2 words. I also tried character sequences of 3 characters. Tried lemmas. Also, I used tree tagger and with 2 types of label sets. They're like the universal label sets and the more fine-grained label sets. Anyways, you see that this is common in machine learning. You try a bunch of different features. That's called feature engineering. And the most accurate model used words, just 1 single word, and sequences of 2 words. So just lexical items. None of these labels and function token tag pairs really helped the model much, right? So it was just the lexical items, which is good, right? But the problem also with support vector machine algorithms is that they're not very transparent, right? So they work like a black box. You give it some data, and then it outputs labels, right? And I'm interested in looking and interpreting and trying to explain language use. So I went the same data, but instead of using support vector machines, I used, also in Python, I used logistic regression. So with logistic regression, you can actually look at the different weights that each feature, in my case here, I'm showing just each word, has to predict some label. So remember that for this native language identification project, I had two labels. This Portuguese text was written by a Spanish speaker, or this Portuguese text was written by an English speaker. So then when I looked at the top words, the top features that had a heavy weight to predict Spanish versus English, you see that the first word for Spanish is Chile. Chile, right? Because it was in Portuguese. So there are a lot of Chileans in Lang8 in this website. So they're talking about their country, right? Because that's when you write journal entries. That's natural to do. Is just write a lot about where you're from and how life is, where you're from, and so on. So that's not very, like, that's more telling of the topic than any indication of cross-linguistic influence. And I'm interested to see if there is anything that Spanish speakers bring to Portuguese when they're learning Portuguese, and that English speakers bring from English to their learning of Portuguese, right? And Chile is just a country, right? It's just a topic. And then if we look at the English, inglés, which is English in Portuguese, it's a feature that is very heavy for their weight to predict English. Like this text was written by an English speaker. Again, this is topic related, right? It's not, it doesn't tell me much about cross-linguistic influence. So that happens, and then we have to be very careful about that, because topic, and if you're grouping your text with some feature like I am with Spanish speakers, English speakers, topic will always help to predict that label. And you can remove this items from your, I could remove these items from my model and run it again, right? And see what would happen. Although that's a problem, there are some interesting things here. So if you look at the Spanish most important features here, I have a lot of preposition plus definite article contractions, like da, do, and na. These, like having taught English to Spanish having taught Portuguese to Spanish and English speakers, these are very hard for English speakers to acquire because that contraction doesn't exist in English. And there are obligatory contractions in Portuguese. And in Spanish, some are contracted and some are not. So it's interesting to see that in Spanish, there are these contractions over here. It may be indication that because Spanish has some contractions of preposition and articles, that this is transferring or it's a cross-linguistic influence. In English, we'll see that there are subject pronouns like eles and ela. English, so Spanish and Portuguese, they are pro-drop languages, right? You can drop the pronoun, the subject pronoun. In Spanish, it's much more common for people to drop the pronoun than in Brazilian Portuguese. But in English, most of the time you need the pronoun, right? So again, this is interesting. It may be an indication that English speakers, they use the pronouns, the subject pronouns, more often than Spanish speakers. So this may be an indication of cross-linguistic influence. All right, so what are the lessons learned for this project? One, content words might be more related to topic than to any underlying cross-linguistic influence or indication of L2 development. there are lots of data available online, like Lang8 is a really nice website with a lot of public data. But metadata, or information about, reliable information about the speakers or the people who produce the text in a corpora, it's really important, right? And like I showed you in Lang8, I went by whatever they were telling the system in their profile what their first language was, but that may not be reliable. The other thing is that some machine learning models are interpretable, like logistic regression, but some are not, like support vector machines and neural nets. And then the purpose many times of these algorithms are more of speed, performance, so to make a really fast prediction, especially if you think about the spam versus not spam email problem. You don't want the system to take a long time to decide to show you the message or not, right? But for my purposes, I prefer to have an interpretable model if I want to use the model to understand language use or language development and acquisition. Okay, so the other topic, the other project I'll be talking today about is the L2 English citation classifier. And this is an ongoing project. So I've been working with CROW, which is the corpus and repository of writing, for 3 years now. Shelley Staples at University of Arizona is one of the principal investigators of this project. And she was also my chair for my committee for my dissertation. So this is like CROW is collected from first-year writing in the United States. So just to give a little bit of context for people who are not familiar with the system in the United States, a lot of university students, they have to take like 1 or 2 semesters of English writing, academic writing, in a lot of universities in the United States. At University of Arizona, there are 2 courses or 3 courses that they have to take in English writing. This project was funded by ACLS digital extensions. And we got a little extension back in last year, 2018 actually, and I'm working on this summer. Okay, so why citation practices? For people who are not into academic writing or studying writing. So citations are an integral aspect of academic writing. They're very important. But they're also known to pose challenges for second language writers. There are a lot of studies on citation practices, but the methods for identifying citations automatically, computationally, do not account for second language practices. So a lot of second language writers, they're very creative in their use of citations. Sometimes, for example, I'm giving an example. We have Silva 2010 argues that, and they cite again, right? So that's usually not a standard practice of published academic articles. And there are more examples of non-standard citation practices that L2 writers in English do that make it hard for methods to identify it computationally being rule-based, right? So a lot of these methods are rule-based. So they have a set of rules. If there are quotation marks, if there are parentheses, this is a citation. So the problem with this rule-based approach for our case is that quotation marks don't always indicate citation. So there are like scare quotes or some emphasis that students, the L2 writers want to use in their text that is not a citation. They're just using quotes. And then citations don't always also contain quoted text, right? So they can do a synthesis of something, but they are referring to an external source, but there are no quotes. So there are a lot of studies out there that used quotes to retrieve citations, but it didn't really work for our data. You can argue that you can go by proper names, right? Proper names don't always refer to a cited author. So I can say 𝗟𝗏 claims, students do something, that's a citation with 𝗟𝗏 as the author. But I can say 𝗟𝗏 claims, and it might not be a citation, right? So like I mentioned, student writers also don't follow citation conventions. So rule-based doesn't really work. So we started this project in 2017, and we presented at 𝗃𝗃𝗋, where we actually coded every citation, every sentence of every text. We had 74 papers by hand. So there were 4 of us. We coded each sentence at least with 2 coders to see if there was agreement, to have other human coders to actually solve any disagreements we had. The motivation for this study is that there are fewer citation practice studies in L2 writing. They're pretty common in L1 English writing, but not in L2 English writing. The paper we wrote about this, where we actually coded a lot of data by hand, is under review. And we ended up with almost 5,300 sentences. That's a lot of coding. It took us a lot of time to code all of this, right? Because like I mentioned, each sentence was labeled by humans, by us, by form. So we had like stuff like integral citation. If I say 𝗟𝗏 2010, right, it starts with a citation that's integral citation. No integral citation, the citation usually comes at the end. If there is a citation, sometimes learners, they just write pages. They just write page numbers, no author, no date. And then also for function, like attribution, statement of use, exemplification, and so on. These were all, this schema for coding, they were all based on previous literature. So our main goal for this paper was to link pedagogical materials with student citation practices. For 𝗏, which is a corpus and repository of writing, we have not only the texts produced by learners, but we also have the materials the instructors used, or the prompts and the rubrics and the sample papers the instructors used for that assignment, right? So we're able to link the practices of students with what the instructors were telling them. And we did find a link, right? Students, they replicated whatever is in the sample materials. And we have a suspicion, like we believe that this hybrid citation practice comes from the rubric, making sure that they were doing the form, like the APA form, and they did like at the beginning and at the end, just to make sure that they were doing it. So from this experience, and the paper is written and is under review, I can tell you hand coding, and a lot of people out there know that it's really time consuming, right? It's interesting because you get to know your data very closely, like you really know your data, but it's time consuming. So my thought was, okay, so now we have 5,000 sentences that have labels, right? They've been coded by humans. So now that we have the data, we can build a statistical classifier. So that's what I did. So for each sentence, we have a label created by humans. And then the linguistic features used in the classifier or in this machine learning model were unigrams, so just lexical items, or individual part of speech tags, and also bigrams, or sequences of 2 words or 2 part of speech tags. So at first, when I built this classifier last year, I used the Berber tagger to get the part of speech labels for each token. But because we want to make this available to other people on an interface, and I have links to these interfaces I will be talking about in a little bit, I thought that the RNN tagger by Schmidt, which is the same person who created the tree tagger, but this is more recent, would be more readily available because anyone can go online, download it. And I thought that would be maybe easier to use than the Stanford dependency parser, but I'm not sure anymore. So I may switch, I don't know. But right now I'm using the RNN tagger. So the texts are tagged. So that means that for each word, there is a part of speech label, if it's a verb, a noun, and so on. So with these features, I did the same thing of splitting the data into training, so the data that my model was actually built on, development, and test. And these are the recall, precision, and specificity for each of the 5 labels for form. So right now I do have the numbers for function, but it's just for form. So I implemented, instead of using Python like I did previously, I implemented this classifier in R, in Tidy Models. Tidy Models is a wonderful package that makes it so much easier to run, to actually train machine learning models and recipes. And for this, I use the random forest algorithm. Like I mentioned, I looked at lexical items, lemmas of these lexical items and part of speech, both 1 gram, so just single ones, and sequences of 2. And the best performing features were lemmas and part of speech tags unigrams, so just single words and single part of speech. So I'm reporting here, instead of accuracy, I'm reporting recall. Recall tells us, gets to how many are missed, right? They were not able to actually get. So integral no citation is the one that is the best performance for recall here. Integral no citation is when they say the author claims that. So it doesn't have a citation with the author name or a page number or a date, but they refer to the author by the author or a pronoun like he, she, and the day, and so on. For precision, precision tells you how many were actually correct from the ones that were classified as such. In this case, no source reference, so the sentence doesn't have any references. It's not a citation. This is the one that performs the best of all of them. And the specificity refers to the true negative. And you see that hybrid are the ones that it has 0 recall, 0 precision, and 99 specificity, because most of them are true negative. We have very little, I have like just a few sentences that are hybrid sentences. All right, so now that I have a classifier, we can combine human and machine into Shiny applications. We have one application that is human calibration. So based on our schema and the data that we coded, we can train new human coders into our schema. And there's also a separate interface for new data. So right now we are in the process of coding 100 new texts. We've done 20 of them, so we have 80 to go. So we have 3 coders. 2 of them were not in the original project, but they were trained with the human calibration. So they were able to learn our schema and how we coded the sentences with the computer and the machine learning model. All right, so let me show you the first interface, and I have the link on the top, and I will be sharing the slides with you, so you'll be able to actually play with this if you want. So for each sentence in bold, the context is given, and then the user selects what label they believe that is. And then the system, the application tells them, the user, whether they agree with the previous human coders, which is the Crow team, and if the machine learning predictions also agree with them. And the reason for the machine learning predictions here is that the second interface, they will also have this machine learning predictions to help them figure out what the label for each sentence is. So yeah, so this is, again, I told you, like and then at the end, it tells you the accuracy rate for the 2 new people we train in this. They started at like 70% agreement with us, the previous humans who coded the sentence, and they ended up with 85% agreement, which is pretty good because some of the sentences are very hard. That's why we need multiple human coders. And that's why we can't really trust the machine to do it like a black box, right? We need this combination of human and machine. So this is for training, what we call like human calibration of humans, right? So humans will learn what the schema is. And then for the new data, we have the whole text, which has been tagged. So we don't tag it. So you have to tag the text with the RNN tagger. And then again here, you have the context, of course, because you have the whole essay. And then for each sentence, there are machine prediction probabilities that tells you what the machine thinks this new sentence is based on the previous data we have. And then the human selects what label they want. Interesting, hybrid, the machine is not sure. It's like everything is 20%. So that's the other reason why I didn't decide to like just output one label. I wanted the user to have the probabilities for all 5 labels, because in the case of the hybrid citation, the machine gets confused, right? Because it doesn't know what it is. So that also, like this one, that also tells the human something about how certain the machine is of that label for that sentence. Yeah, so this, like I said, this is we're using it right now. We have 3 coders, me and 2 other people. So we are still looking for human agreement. Okay, so the implications of this project. So balancing human coding and machine learning leads to a more transparent and interpretable results. Transparent coding of this kind of thing, like when humans have to code data, allows for replication studies and does direct comparisons. A problem in any field, not only applied linguistics, is that many times the schema for coding is different for different studies, or people are not very detailed about their schema. So it's hard to compare 2 studies if you don't know if they were coded the same way, right? So with these interfaces, which allows humans to be trained in our schema and to actually use the machine predictions to code new sentences, we're hoping that this will be more standardized so we can compare results from different studies. Having humans interact with machine learning models leads to a greater understanding of how machine learning works. So it's not a black box, right? We know that it's like it predicts with a certain certainty. So that also helps, demystify some of the machine learning techniques. Models built for L2 sources are important because L2 writing or L2 language can have more variation, so it can be a little harder to code or build or reuse machine learning models that were built on native language or L1 data. And we found that using lexes and grammar, so the part of speech tags, they do provide some like shallow information about grammar features, improves the model. So it's not only the lexical items. Okay, so future directions. So like I mentioned, we're currently working on using this form classifier to code 100 texts from different L1 backgrounds, different universities, and different genres. An agreement interface is under development. So now I have to think about like, okay, we have 3 human codes, labels for each sentence, and the machine learning predictions. How do we decide who is right? So we're reading the literature to see how we can go about that process. And probably I'm going to create a new interface for that to have another human who has never seen the data to resolve any disagreements. The function classifier is already implemented. It's just that we need to do some tweaks. I need to actually have people use it to see how it's working. And I'm also training more applied linguistics this summer into building these machine learning models in R. So if you want to start with machine learning, you should. Coding is not that hard. It's much easier than you think it is if you don't know how to do it. Python is really a great programming language, and it has a really good community. R is a little different than other languages. Basically, Python follows the same kind of way of thinking than many programming languages, so you can transfer the knowledge to other programming languages. R, not so much, because there are certain things that are very specific to R. So it may be harder for you to transfer your knowledge if you start programming R to other programming languages. R has a better community, though. Python has a great community, like I said. But R, like you Google something, it's out there. People are willing to help you. So that's why if you're not thinking of being a software developer that you need to work with multiple languages, I would say go with R, because you can do a lot of stuff like building interfaces, and people are willing to help you. I gave an intro to R workshop a few weeks ago. So this is the link. Again, I will make the links available to you. If you want to start and you're new to all of this, there is a great free book of text mining in R that gives you the basics of what you need to do to deal with corpus linguistics or machine learning. Stuff like how to tokenize your data, how to count how many words you have, how to have a normed frequency for each word per text, and so on. Highly recommend. It's free online. There is also a gentle intro to tidy models from RStudio. There is available online. And my last tip is like collaborate. Find people that want to learn, or they know a little bit more or a little bit less than you. Work together. Make a group where you go through courses. There is here in Tucson, for example, I'm the founder of R Ladies, which are, we have like monthly workshops in R. There is also groups with Python. There is PyGirls. I know there is a lot of these groups in São Paulo. So find these people. They want to teach you. Just go for it. And you can always email me if you have questions. You can follow me on Twitter at Adriana Picoral. I am always sharing resources and webinars that are going on.